Welcome back, ladies and gentlemen. Our focus today is going to be on the concept of average atomic mass. And the way I want you to think about average atomic mass is how your grades are calculated in your classes. Odds are tests are worth a certain percentage of your grade, quizzes are worth a certain percentage of your grade, homework and labs are worth a certain percentage of your grade. And average atomic mass works that way as well. So hopefully you'll be able to see some of the connections between grades in some of your classes and the concept of average atomic mass. So our goals today, hopefully you will be able to understand the idea of atomic mass and how it is determined on the periodic table, and also be able to calculate the average atomic mass given a percent abundance of each isotope of that element. So we got a few new vocab terms for you for today. We have the atomic mass unit and the average atomic mass as our key vocab terms for this video. So keep in mind that when we talk about the mass of an atom, that the masses are very, very small. And we need a specific unit to measure the mass of a particular atom. So we use what's called an atomic mass unit, or an AMU. An AMU is equal to the mass of one proton or one neutron. So for example, an atom of carbon-12, which has 6 protons and 6 neutrons, has an atomic mass of 12. We've talked a little bit about this already in our previous unit when we talked about atomic mass. So the atomic mass is 12. It would be representative of 12 atomic mass units. Now keep in mind that on the periodic table, most elements are a mixture of isotopes. So if we look over here on the right, you see that lithium has 3 protons and can either have 3 or 4 neutrons. Well, we have to average that out based on the abundance of those elements in nature, and that's where we get the number below, which is the atomic mass. You're going to be using the atomic mass very frequently in this class. Now it is considered what's called a weighted average, meaning we need to know the abundance of each substance. Since lithium can occur as lithium-6 and lithium-7, because the average atomic mass is closer to 7, we would say that there is a higher abundance of lithium-7 than lithium-6. Now keep in mind, this is also the number that's found on the periodic table, so we'll be using this average atomic mass quite frequently. So what we're going to do now is look at how we can calculate a weighted average, and it's pretty easy to do. So here's our first practice problem. Determine the average atomic mass for a sample of copper if 69.15% of the sample is copper-63 and 30.85% is copper-65. Well, we need to first know the masses of copper-63 and copper-65, and fortunately, they're already given to us. Copper-63 has a mass of 63 atomic mass units, or 63U, and copper-65 has an atomic mass of 65U. So in order to do a weighted average calculation, we just multiply the atomic mass by the percentage, and we do this for each isotope that we have. And then what we do is we just add the numbers together, and we get our average atomic mass. So here, 69.15% is converted into a decimal, so that would be 0.6915, and we're going to multiply that by 63U. We're also going to take 30.85%, convert that into a decimal. We get 0.3085, and we're going to multiply that by 65. And then whatever we get for our two answers, we just add them together, and that will be our average atomic mass. A little bit of a shortcut, or I should say a shortcut, a little more bit of a trick here. Your average atomic mass should always fall in between the lowest and highest mass. So if we look here, our lowest mass is 63 and our highest is 65. Therefore, our answer should be somewhere between 63 and 65. You never take an average of numbers and then expect it to be higher than the highest number or lower than the lowest number. That wouldn't make sense. So it's a pretty easy calculation, but let's do one together just to make sure we're all on board. If the abundance of rubidium-85 is 72.2% and the abundance of rubidium-87 is 27.8%, what is the average atomic mass of rubidium? Well, again, we need to look for our givens. We're given rubidium-85 is 72.2% and rubidium-87 is 27.8%. And the question is asking for the average atomic mass. So this is just going to be like the calculation we just did. So rubidium-85 has a mass of 85. And we're going to multiply that by 72.2% as a decimal. So it's going to be 0.722. And then we're going to add that to rubidium 87, which has an atomic mass of 87, and we're going to multiply that by 27.8% as a decimal. Okay. Remember that we're talking about average atomic mass, so we're talking about U's here. And then we just plug into our calculator and solve. And we get our answer, which is 85.56. Okay. You may also see this in another unit, which is grams per mole. But we will talk a little bit more about that in our next unit. Okay? So pretty straightforward. Take the mass multiplied by the percentage and add that to the mass multiplied by the percentage. You get your answer. It's the same if you have 3 of these or 4 of these or even 5 different percentages. The process is still the same. Hopefully this makes sense. So hopefully now you have a pretty good idea of how the masses of atoms are measured, and they're measured in what's called atomic mass units, which are roughly equal to the mass of 1 proton or 1 neutron. The masses found in the periodic table are weighted averages of all of the isotopes of that element, and hopefully you found out they can be very easily calculated. I really appreciate your time, guys. Thank you for watching this video. I hope it makes sense, and we'll do some more practice with this here in the near future. So take care, guys. Have a good day. Bye-bye.